student is trying to prove this identity. We have to identify 3 errors that they've made. So they start by letting x equal arctan of A and y equal arctan of B. Nothing wrong with that. And then they get these results. That's okay. And they decide to find tan of the left-hand side, which becomes tan x minus y. No problem with that. But tan x minus y, there's an addition formula for that. It's actually tan x minus tan y all over 1 plus tan x tan y. And tan x tan y is not equal to tan squared xy. So this here is a mistake. All right, next mistake. So they then replace tan x and tan y by a and b respectively. However, tan squared xy that they have put in equals tan xy times tan xy. And this is not equal to a b all squared, since ab all squared is actually equal to tan squared x tan squared y. So that is a mistake right here. And then if we keep going, actually there's nothing wrong with this line, that is okay. But if we factorize out a minus ab, just that part there, then we actually get a times 1 minus b, rather than a times 1 minus ab. So this here is a third error. And there is an error on this one as well, but it's the same error, so I'm not going to count that twice. So those are the 3 errors that the students made. We're asked now to write a correct proof of the identity. So I'm going to start, I haven't quite got space for it, but I'm going to start by doing exactly the same thing that the student did here. And then even writing that down. So imagine I've already written that. Then I'm going to get, using the correct identity, tan x minus tan y all over 1 plus tan x tan y. But all we need to do now is replace tan x by a, replace tan y by b, and and do the same at the bottom as required. So it's actually a very quick proof. Actually, it's not quite as required because that is for, remember, that is actually for tan of arctan A minus arctan B. So therefore, if I write it back as arctan A minus arctan B, then it's going to equal, now I need to do arctan of this thing that I just found. Okay, and then the proof is complete. We now link into a mechanics question. So balls are projected one after another from a point A above horizontal ground. Each ball travels in a vertical plane towards a 6-meter high wall of negligible thickness, a distance 10 root 2 meters from A. The balls are particles, there's no air resistance, and they're projected at 28 meters per second, which is indicated at a random angle. And then we're given that the ball will pass over the wall when theta is between 2 values, because if it's too high, if theta is too big, it's just going to come up and back down. or it's going to not quite meet the wall. And if it's too low, it's clearly just going to hit the ground first. There's going to be a minimum and a maximum. And we're asked to find in degrees the angle beta minus alpha. Okay, let's do this. So I've got my diagram. Just going to add a few key details. First up, the wall is 6 meters and we are 10 root 2 meters away from it when we start. Actually, I think that is everything. So I'm going to look at A to the wall, this part of Suvat. And I'm going to look at the horizontal motion and the vertical motion. So first up, horizontal motion. We're traveling 10 root 2 meters. The initial velocity, we can resolve our 28 into its components. So over here we have 28 sine theta, and here 28 cos theta, and then we have a right angle. So u here is going to be the cos one. There's actually no acceleration horizontally because there's no force horizontally, so A is 0 and B remains as 28 cos theta. And this means that the formulae for Suvat, they basically just become S equals ut, or become speed is distance over time. So time is S divided by u, so 10 root 2 divided by 28 cos theta. We could simplify that, but I'm going to leave it like that for the moment. Let's look at vertically. So now u is 28 sine theta. A is going to be minus 9.8, as we were told. And we're interested in the point where the ball just goes over the wall, because we're going to be looking at the maximum and the minimum. Now, just note this, it starts at 1 meter above the ground. So actually we want S to equal 5. Okay, that is easily a place to slip up here. S equals ut plus a half at squared, which means that 5 is equal to 28t sine theta. A half times minus 9.8 is minus 4.9 t squared. We're in the process of running, generating the equation of motion to some extent. It's just that I'm using 5. I've actually got values, but we don't know what theta is, so it's still the same sort of steps that you should have seen when deriving equations of motion in terms of x, the horizontal distance, and y, the vertical distance. In fact, you might even be more comfortable generating that and then substituting in 10 root 2 and 5. I've gone straight for it because it's not asked us about the general case. So what we can do now is combine these two together. I can replace my t's by 10 root 2 over 28 cos theta. Therefore, 5 will equal 28 sine theta multiplied by 10 root 2 over 28 cos theta. That's why it's quite good not to simplify it, because these now cancel out. Minus 4.9 multiplied by 10 root 2 over 28 cos theta all squared. All right, that's looking pretty good. Over here, I get 10 root 2 times sine theta over cos theta. We tend to try and write it in terms of tan theta because we can get the whole thing in terms of tan theta. And then over here, I'll get, I'll square root 2 to give 2, square 10 to give 100, so it'll be 200. So 200 times 4.9 divided by 28 squared, and then we write sec squared theta. Now remember, sine squared plus cos squared is identical to 1. Divide through by cos gives tan squared plus 1 is equal to sec squared. Okay, here we go. Now let's simplify this. The first thing I can do is divide through by 5 because there's a common factor. And then I don't really want to work out 28 squared, so I can remember it's actually 28 times 28, and I can divide each through by 2. If I divide top and bottom by 4, so I get 10, and then 14 times 14. That's looking much better already. 10 times 4.9 is 49. And then actually, I can divide top and bottom by 7, which makes this a 2 and this a 7, and the same again. Okay, and it's all gone. Sorry, it's just become 1 now. So to tidy up, 1 is equal to 2 root 2 tan theta minus a quarter tan squared theta. Actually, let me expand the bracket while I'm at it. Minus a quarter. All right, I'm not a fan of that quarter, so I'm going to times through by 4. So 4 equals 8 root 2 tan theta minus tan squared theta minus 1, which means we're getting there nearly. Tan squared theta minus 8 root 2 tan theta plus 5 is equal to 0. Oh, okay. That was quite a lot, wasn't it? That's harder than your typical question on equations of motion. So we've worked through writing down essentially the equation of motion. We just put in x and y. We're working in terms of the angle here. We've got the formula as normal. And then without a calculator, we've had to deal with this quadratic in tan, simplifying it really carefully. And we've ended up with this. So time for the quadratic formula, I think. Tan theta is going to equal minus b, so 8 root 2, plus or minus 8 root 2 squared. So 8 squared is 64, root 2 squared is 2, so 64 times 2 is 128. Minus 4 AC, 4 times 1 times 5, so minus 20, all square rooted, all over 2. This becomes 4 root 2 plus or minus, it's going to be 108, which is 27 times 4 all over root 4. So these cancel, and we've got 4 root 2 plus root 27, or 4 root 2 minus root 27 as our two angles where we're going to precisely hit the top of the wall. Now let's just recap what we're actually trying to find. We're trying to find the angle beta minus alpha, where beta is bigger than alpha. So just recall that tan is actually an increasing function over the interval that we're interested in. In fact, it's sort of always increasing, except it obviously has these discontinuities. So it must be that tan alpha is the smaller of the two, which is when we're subtracting. 4 root 2 minus root 27. and tan beta is 4 root 2 plus root 27. This is because alpha less than beta and tan is an increasing function. So remember, we actually wanted to work out what alpha minus beta was, or sorry, beta minus alpha was. So alpha is going to be inverse tan of 4 root 2 minus root 27, and beta similar. Sorry, that should have been a plus. But let's not forget the result we showed earlier on. This one here. Okay, and I can sense that we are pretty close. So this is A for us, and this is B. And therefore the answer is going to be inverse tan of 4 root 2 plus root 27 minus 4 root 2 minus root 27. Oh, sorry. I was just trying to fit it all in. Anyway, that's okay. Over 1 plus 4 root 2 plus root 27 multiplied by 4 root 2. Sorry, that should make mistakes here, but fortunately I've spotted it. There we go. Oh, we've just got to find inverse tan of that. Right. Well, presumably this is going to simplify. In fact, the minus 4 root 2 is going to cancel with the plus 4 root 2, which is going to give us 2 root 27. And over here, we'll get 1 plus 4 times 4 is 16, times 2 is 32. And then this is going to become a difference of 2 squares. So we're going to get a minus term and a plus term, so we can just cancel them. So we just end up with a minus 27. Amazing. I'm just going to simplify the third. So 9 goes into this. So root 27 is equal to root 9 root 3. So it's 3 root 3, which means twice that will be 6 root 3. And then 33 minus 27 is 6. So we simply get inverse tan of root 3. And this has an exact value. It's 60 degrees. So that is the difference in the two angles that just about get us over the wall. Wow. Okay, now that was the main part of the question, but there is a little bit more. And in fact, some statistics is now brought into this. Deduce that the probability that a particular ball, will pass over the wall is 2/3. So there's a 60-degree range of success. And theta can vary between 0 and 90. Therefore, probability of success, that is to pass over the wall, will equal the range that we can get to pass over the wall divided by the total possible range, which implies to 6 over 9, or 2/3. We're going to fire 10 balls, so this becomes a binomial distribution. Let x be the number of balls that pass over. X follows a binomial distribution with 10 trials, probability of success 2 over 3. We're asked to find the probability that exactly 2 pass over. That probability that x is equal to 2. And that will equal 10c2, or 10 factorial over 2 factorial, 8 factorial. Let me just talk a little bit about where that comes from. Hopefully you've gone in depth on the binomial distribution, but if not, here I am. So we've got 2 successes and 8 failures. And if you do a little bit of learning on arrangements, you find that there are 10 factorial ways of arranging 10 distinct objects, because there's 10 choices for the first, then 9 for the second, then 8 for the third, and so on. But in this case, where some of them are repeated, I could swap the two s's around, for example, and I'd get the same arrangement. So I've double counted, I need to divide by 2, or we could write it as 2 factorial. And then I could also swap all the f's around. So I need to divide by 8 factorial for all the different ways that they could be arranged. Okay, and then for one particular set of 2 successes and 8 failures, it's going to be 2/3 to the power of 2. Along my tree diagram, success followed by success, followed by 1/3 to the power of 8. Now, I didn't really pay much attention to this, but we're asked to write the answer in the form p over q to the power of k, where there's no common factors, essentially. P over q to the k. All right, just bear that one in mind. So first up, I'm going to simplify this, which will become 10 times 9 times 8 factorial over 2 times 8 factorial. So they cancel out, leaving me 90 over 2, or 45. So I'm going to get 45 multiplied by 4 over 3 squared times 1 over 3 to the 8. See, I'm not going to work them out because that's going to be my q to the power of k. Now, actually, one of these, 9 goes into 45, so that is actually worth working out. So I've got 5 times 4 over 3 to the 8. So my answer is going to be 20 over 3 to the 8. That is my answer. That's my final probability. We've got one more part to this question. Let me do it in a different color, actually. So the question says, explain whether taking air resistance into account would increase or decrease the probability. So what happens with air resistance? Air resistance will mean the balls travel less far. There will be a lower angle range. or a smaller angle range for getting over the wall. So a lower probability. But this actually means that there'll be a higher probability of failure. And so the probability of just two successes will actually increase because that's when we get lots of failures. We expect to get less over, and so we expect to get a smaller number of successes, more zero successes, more one successes, more two successes, and let's say eight successes and so on. All right, now that is a good question. The projectiles bit was really interesting, I think. Awkward, but I hope you're happy with everything we did. Bringing in that tan identity was pretty awesome at the end. And then just tagging on a little bit on statistics. Um, and the nice thing about this is even if you got stuck with part one, you can still do the probability parts because it's a deduced part. So they're kind of being nice that you'd lose this mark if you couldn't use the 60 over 90 to get it, but then you could still talk about the rest. I enjoyed that. I hope you did as well. Well done.